Somewhere far from the sun, in the cold between the stars, a single ship is moving through the dark. Inside it is everything that is left of us. Earth is gone or dying, a pale point somewhere behind. And these are the people who got out, the ones who stayed alive by leaving. Every breath they take was made by a machine. Every drop of water has been used 1,000 times over. Outside the hull there is no air, no warmth, no help, and no ground anywhere for trillions of kilometers in any direction. This is the picture we reach for when we imagine the end of Earth and the survival of our kind. We climb aboard a ship, we sail away, and we carry on. We stayed, but staying is a promise, and tonight I want to find out whether it is one we could ever actually keep. Not for a year, not for 1,000 years, all the way to the end. Tonight, we are going to find out whether humanity could survive the death of Earth by living in a ship out in deep space, and how far that survival could possibly stretch. By the end of this, you will understand what it would take to keep a human world alive inside a sealed hull for thousands of years, which worlds we could actually run to, and how long the crossing would take, and what waits in the dark between the stars, including whether anyone is out there to meet us. And you will understand the one enemy that no ship can ever outrun, the reason that surviving until the true end of everything is a different question, and a far colder one than simply surviving the loss of Earth. If you like the kind of question that does not let you look away, a subscribe is how you keep them coming. Now, let us begin. Start with the fact that makes this whole question real, and not just a story. Earth is not permanent. One day it will become uninhabitable, and we know this for certain, because the thing that will end it is no maybe and no roll of the dice. It is the sun, the same star that warms you right now, is slowly, steadily getting brighter as it ages, and that brightening never stops and never reverses. In about 1 to 1.5 billion years, it will be pouring out enough heat that Earth's oceans begin to boil away, and the surface we evolved on stops being able to hold complex life at all. No technology stops that. No clever fix turns the sun back down. Long before the sun swells into a red giant some 5 billion years from now, the world will already be a dead one. So the eviction notice is real, and it is already written. The only open question is the date, because a nearer disaster, a great impact, something sudden, could move the deadline up, while the sun sets the absolute final limit. Either way, there comes a day when staying on Earth is no longer an option, and the only humans left are the ones who found a way to leave. That is the premise of everything we are going to talk about tonight. Not whether we would want to go, whether, when we have to, we could. To see what a world looks like after it loses this fight, you do not have to imagine anything, because there is one right next door. Mars is what finished looks like. It is a cold, dry shell of a planet that billions of years ago had a thicker atmosphere and liquid water running across its surface, and then lost almost all of it. Its small core cooled, its protective magnetic field switched off, and the solar wind stripped its air away into space over hundreds of millions of years, until what was left was the rust-coloured desert we see now, where the average temperature sits around 60 degrees below zero, and the air is less than 1/100th as thick as ours. Mars had its warm, wet moment near the beginning, and then it died about 4 billion years ago. When we picture fleeing a dying Earth, this is the kind of place the universe is full of. Not fresh new worlds, the aftermath of old ones. Here is the thread I want you to hold from the very start, because the whole video hangs on it. Everything alive runs on warmth. Not warmth as a feeling, but warmth as a physical fact, heat flowing from something hot into something colder, and doing a little work along the way. Your body does it, a fire does it, a star does it, and on Earth that warmth has always been free, poured down on us by the sun for nothing, every single day, for as long as there has been life here at all. We never had to make it, we never had to carry it, It was simply there, falling out of the sky. The day we leave Earth is the day that stops being true. Out beyond the sun's reach, no one hands you warmth for free. A ship in deep space is cold, lethally cold, and every scrap of heat keeping the people inside it alive has to be made and carried and guarded by them. So the act of surviving away from Earth is, at its root, the act of carrying your own warmth into a place that has none and keeping it going. Hold that idea. We are going to follow it all the way to the end of the universe, and it is going to decide the answer. It is worth understanding why the sun brightens at all, because it is the one doom that is truly certain, and the reason is buried in the star's own heart. Deep in the core, the sun fuses hydrogen into helium, and the helium left behind is heavier and gathers in the center, packing the core down tighter and hotter over time. A hotter, denser core burns faster and shines brighter, and so the sun grows steadily more luminous as it ages, by about 10% every billion years or so, and there is no switch to turn it off. This is not the sun running out of fuel and dimming, it is the sun running well and getting hotter for it, which is the crueler version, because the thing that warms us is also the thing that will eventually cook us. And it does not even take the full boiling of the oceans to end us. Long before the seas are gone, the rising heat tips the climate into what is called a moist greenhouse, where more and more water vapour fills the air, traps yet more heat, and drives the whole system toward a runaway. Somewhere in that first billion or so years from now, the surface crosses a line past which complex life can no longer hold on, even though the planet still looks, from a distance, like a blue and living world. The eviction does not wait politely for the very last drop of water to boil. It comes when the warmth tips from gift to threat, and that turn is already scheduled. I find it steadies the mind to set that clock against the history of life itself, because the numbers cut both ways. Life has existed on Earth for something like 3.5 to 4 billion years. Complex, many-celled life, the kind that builds bodies and minds, has been here only around 500 million. So the time we have left before the brightening sun ends it all, somewhere above 1 billion years, is actually longer than complex life has so far existed at all. We are not standing at the end of the afternoon. We are somewhere in the middle of it, with a long stretch of daylight still ahead, which is exactly why the question of leaving is not a panic but a problem, something we have real time to either solve or fail. But hold the harder truth underneath the comfort. Time to prepare is not the same as a way out. No matter how much daylight is left, the day still ends, and when it does, the only humans who continue are the ones who learn to live without the free warmth of the sun. Mars already lost its warmth and its air, already went from a world with rivers to a frozen shell, and it did so because it could not hold on to what kept it alive. When we look at Mars, we are looking at the after, the state every warm world eventually reaches, when the thing feeding it finally stops. Earth's after is coming too. The only question this whole video asks is whether we could carry ourselves through it, and on into a universe that is itself, very slowly, doing the same thing the sun will do to Earth. It is worth following the sun a little further into its own future, because its death is the model for everything this video is about. After the oceans are gone, the sun keeps aging, and in about 5 billion years it swells into a red giant, ballooning out until it swallows its innermost worlds and scorches the rest. Mercury and Venus are very likely engulfed outright, and Earth, if it survives being swallowed at all, is left a burnt cinder orbiting a bloated dying star. So the sun does not simply stop warming us. It turns on the worlds it once warmed, the same generous star becoming the thing that destroys them. That arc, from giver of warmth to destroyer, is the universe in miniature, and it is exactly the arc we are going to watch play out on the largest possible scale, with every star there is. Our sun is just the first instance of it we will have to outlive. And the sun is only the guaranteed ending, not the only one. which is part of why this question is not idle. Long before that slow stellar clock runs out, the nearer dark could move the deadline up without warning. A large enough asteroid, of the kind that has struck before, could wreck the surface in an afternoon. A nearby star could die in a violent burst and sleet the Earth with radiation. These are rare, scattered across tens of millions of years, and we cannot predict them, which is exactly what makes them dangerous, because preparation needs time and they grant none. So the picture is not that we have a billion comfortable years and then a tidy exit. It is that we have a long but uncertain stretch, with a certain ending at the far end, and the small constant chance of a sudden one before it. Either way, the conclusion is the same. A species that means to last cannot stay on one world forever, because one world is one accident or one aging star away from taking everything with it. I think the deepest thing Mars and the Sun teach together is how much we have been given for free, and how briefly. Right now, every scrap of warmth that keeps you alive arrives without effort, poured down from a steady star onto a world with air and water already in place. We did not build any of it, and we pay nothing for it, and it has simply been there the whole time. Every option we have been talking about tonight, the ship, the new world, the scavenged embers, is an attempt to replace that free gift with something we make and carry and guard ourselves at enormous cost, and never as well. That is the real measure of what leaving means. Not adventure, but the end of the only free warmth we will ever have, and the start of paying forever for every degree of it. So the eviction is coming, on a clock we cannot stop, and the only survivors will be the ones who left, which forces the first real question, the one most people skip straight past on their way to imagining new worlds. Before we ask where we would go, we have to ask whether we could even live out there at all, with no planet beneath our feet, sealed inside a machine with no world around it. Could a ship ever truly be a world? A starship that carries the last of us would not be a vehicle, it would be a sealed world, and that is a far harder thing to build than a fast engine, because it has to make everything it needs by itself for longer than all of recorded history, with nothing coming from outside ever again. Think about what a real crossing demands. Not a trip of days or months, but one of thousands of years, through a place where there is no air to breathe, no water to drink, no soil to grow food in, and no way to call for help that would arrive in less than a human lifetime. Everything a living person needs has to be produced inside the hull, recycled, and produced again in an unbroken loop that cannot fail even once. We have tried to build sealed living worlds before, here at home, in the easiest possible conditions, and we have struggled badly. When people have sealed themselves inside closed habitats meant to recycle their own air and water and grow their own food, the delicate balance has drifted out of control within months. The mix of gases in the air shifted dangerously, crops failed, the tiny artificial world could not hold itself steady even for a year or two, even with breathable air waiting one wall away and the whole of Earth ready to help. Now take that same fragile, barely managed task and remove the planet, remove the rescue, remove the open door. Demand that it run flawlessly sealed for 10,000 years. That is the standard a real starship has to meet, and we are nowhere close to meeting it. And the loops are not only about air and water. A ship that travels for millennia has to be able to repair and replace everything it is made of, which means it has to carry, in some form, an entire industry. Every pump, every wire, every seal wears out eventually, and there is no factory at the next stop, no spare parts waiting anywhere ahead. To stay alive, the ship would have to mine, refine, and manufacture its own replacement parts from whatever it carried or could gather along the way, endlessly, for the whole crossing. We have never built a machine that can rebuild itself like that. Not for a decade, let alone for an age. Then there is the hardest cargo of all, which is people. A ship crossing to another star on the timescales we can actually reach would take so long that no one who boarded it would live to arrive. It would be a journey of generations, where children are born, grow old, and die in the void, and only their distant descendants ever see the destination. That raises a brutal question of numbers. How many people do you need to start with so that the group stays healthy across all those generations and does not collapse into too small and too inbred a population to survive? When researchers actually ran the numbers for a multi-thousand-year crossing to the nearest star, they found that the bare minimum, under careful rules, was around 98 people, and that more cautious estimates push the safe number into the thousands. So a real ark is not a handful of brave pioneers. It is a whole town, sealed in a can, kept perfectly alive for longer than humans have had writing. I want to be fair, because none of this breaks any law of nature. There is no physics that forbids a self-sufficient ship. It is an engineering and biological problem, not an impossible one, and given enough centuries of work we might learn to do it, but could in principle, after a great deal of work we have barely started, is a very different thing from ready. Right now, today, we cannot keep a sealed world alive for even a few years. The ship that carries our warmth into the dark, the single most important machine we would ever build, is one we do not yet know how to make. So picture it as it would really be. A single lit speck crawling through total black, with the sun shrunk to just another star behind it and no world anywhere in front. Inside, a town of people, breathing air a machine remade from their own breath, drinking water that has been through their bodies 1,000 times, eating food grown under lamps, every joule of warmth made and hoarded against a cold that would kill them all in minutes if the walls ever failed. That is what carrying our own warmth actually looks like. A fragile bubble of made heat, alone, for 10,000 years. To feel why a sealed world is so hard, look closely at just one of its loops, the air. On Earth, you breathe in oxygen and breathe out carbon dioxide, and the whole living planet quietly turns that carbon dioxide back into oxygen for you, on a scale so enormous that you never have to think about it. Inside a ship, there is no planet to do that. The carbon dioxide every person breathes out has to be captured and broken back down into breathable oxygen by machines, endlessly, with no gap. Because the moment that loop falls behind, the air itself begins to turn to poison, and that is only one loop. The water has its own, the food has its own, the waste has its own. Each must close perfectly and stay closed, and each is tangled with the others, so that a failure in one can cascade into all of them. A crop dying and taking the oxygen and the food supply down together, with no shop to visit and no shipment coming. Then there is the question almost no one asks, which is where the warmth and the power even come from. Out between the stars there is no sunlight worth the name, so a ship cannot run on solar panels the way a craft near the sun can. It would have to carry its own source of energy, almost certainly something nuclear, a reactor burning its fuel slowly across the centuries, because that is the only thing compact enough to pour out steady power through the dark for thousands of years. Every breath made, every drop of water cleaned, every lamp over every crop, every degree of warmth held against the killing cold outside, all of it draws on that one carried store of energy. The ship is not just a sealed world, it is a sealed world with a single fire at its heart that must never go out, and no way to relight it if it does. And then there is the strangest problem of all, which is people across time. A crossing of thousands of years means hundreds of generations are born, live and die inside the hull, never seeing the world that was left, and never seeing the world ahead. The people who launch the ship choose to go. Their distant descendants never chose anything. They are simply born into a metal world in the dark, asked to keep it running for a destination they may not believe in, and a home they have only heard about. Knowledge has to survive all those generations intact, every skill needed to fix every system passed down without a break. Because if even one crucial craft is forgotten, if the people who knew how to repair the reactor or balance the air die before teaching the next ones, the whole ship can fail not from any disaster, but from simple forgetting. History is full of knowledge being lost in far easier conditions than a sealed can crossing the dark. So the sealed world is not only an engineering problem, it is a problem of holding a whole civilization steady, its machines and its knowledge and its will, for longer than any civilization on Earth has ever lasted, with no margin for error and no help. We have never done anything remotely like it. And remember, all of this is still the easy half of the question, the part that is at least possible in principle. We have not yet even reached the thing that no amount of skill or care can fix. First, though, the distance, because the distance is where the dream first meets something solid. The food alone is a problem most people wave away and should not. A ship cannot pack 10,000 years of meals, so it has to grow its food as it goes, which means farms inside the hull, lit by lamps that run on the ship's one carried store of energy, in sealed spaces that hold their own air and warmth against the killing cold outside. Every calorie eaten by every person across hundreds of generations has to be grown, harvested and regrown in a closed cycle where the waste of one crop feeds the next and nothing is ever thrown away because there is nowhere to throw it and nothing to replace it with. A blight that sweeps a crop on Earth is a hardship. The same blight in a sealed ship with no other fields and no shipment coming is a slow death sentence for everyone aboard. Feeding a town in a can for longer than human history is not a detail to be solved later. It is one more thing that has to work perfectly, forever, with no margin at all. And there is a danger to a sealed town that has nothing to do with machines, which is what happens to people who are born into a mission they never chose. The first crew leaves with a purpose burning in them, a dying Earth behind, and a new world ahead. But 50 generations later, the people aboard have never seen Earth and will never see the destination, and the whole reason for their strange metal existence is something they know only as a story handed down. Will they keep tending the reactor and the crops for the sake of descendants they will never meet, on the word of ancestors long dead? Or will the purpose fray, the discipline slip, the careful knowledge rot, until the ship drifts on with a crew that no longer remembers or believes why they are there? A starship has to carry not just air and food and warmth across the centuries, but meaning, and meaning is the most perishable cargo of all. We have watched empires forget their own founding in far less than 1,000 years, on a whole planet with everything to remind them. A town in a can has nothing to remind it but itself. And even the ship's own fire is borrowed, not endless. A reactor burning steadily for 10,000 years still burns through fuel, and fuel is finite, carried from the start, or gathered with enormous effort along the way. So the warmth at the heart of the ship is not a free and lasting flame, but a measured store being spent, every year a little smaller, exactly like everything else in this story. The ship does not escape the basic predicament. It carries it, a finite store of warmth, hoarded against an infinite cold, running down at whatever rate the people can bear to spend it. That is the shape of survival away from a star, and it is a preview in miniature of the shape of survival in the whole dying universe. A fixed amount of fire, and forever to try to make it last. And because nothing can be allowed to fail alone, a real ship would have to carry backups of its backups, 2 of every critical system at least, and the means to build a third, because a single point of failure anywhere in a machine running for 10,000 years is a single point at which everyone dies. That redundancy is more mass, and more mass is more to push and more to slow, and more to shield, feeding straight back into every other problem. The ship grows heavier the safer you try to make it, and heavier means slower, and slower means longer in the dark, and longer in the dark means more chances for the very failures the redundancy was meant to prevent. Every solution on a starship buys its safety by making some other problem worse. That is the quiet trap at the heart of the whole design. There is no version of it that is simply easy. But before we go any further, there is one thing I have to leave with you, and I need you to carry it through everything that follows. There is one enemy waiting at the end of every escape we could ever plan. It is not the distance, and it is not the cold, and it is not whatever might be hiding in the dark ahead of us. No ship outruns it. No new world hides us from it. No amount of cleverness or speed defeats it, because it is built into the universe itself, and I will come back to it. Hold on to it. Say we could build that sealed world. The next question is where it would go, and the answer is humbling. The very nearest world we might run to, the closest planet beyond our own solar system that could even arguably hold life, is called Proxima Centauri b, and it orbits the nearest star to the Sun. That star is about 4.25 light years away. Light, the fastest thing there is, takes more than 4 years to cross that gap, and we do not travel anything like the speed of light. At the speed of the fastest object we have ever launched, a probe that whipped around the Sun at about 200 kilometers every second, reaching Proxima Centauri b, would still take somewhere close to 6,300 years. At the gentler speed of the Voyager craft, the ones that have actually left our solar system, the same trip would take around 75,000 years. Let those numbers sit for a moment, because they are the real shape of the problem. The nearest possible refuge is a journey longer than all of human civilization, by our best real speeds. Everything we have ever built, every city, every language, every recorded life, fits inside a span shorter than a single one-way crossing to the closest star. When people say we will simply go to another world, this is the distance hidden inside the word simply. And if Proxima Centauri b feels too close to count on, the next famous candidates are much further still. The TRAPPIST-1 system holds 7 planets close to Earth's size, 3 of them in what we call the habitable zone, and it lies about 40 light years away, roughly 10 times the distance to Proxima. 40 light years is nothing on the scale of the galaxy, a step across the room, but at our real speeds it is a crossing of hundreds of thousands of years, a number that turns the word neighbour into a cruel joke. Now here is the part that should trouble you most, because it is easy to miss in the excitement of finding planets at all. That phrase, the habitable zone, promises far less than it sounds like. It only means the planet orbits at a distance where the temperature could, in principle, allow liquid water. It says nothing about whether the world actually has air or water or anything a human could use, and the nearest candidates have a serious problem hanging over them. Both Proxima Centauri and the TRAPPIST-1 star are small red dwarf stars, dim and cool compared to the Sun, and red dwarfs are violent. They erupt with flares, blasts of radiation far stronger, for their size, than anything our calm Sun throws out. The TRAPPIST-1 star flares roughly 6 times a day. 6 times a day, every day, for billions of years it has been bathing its planets in bursts of radiation. What that does to a nearby world is strip it. A planet hugging close to a flaring red dwarf, which it must to be warm enough at all, can have its atmosphere slowly torn away and blown off into space by that relentless radiation, exactly the way the solar winds stripped Mars long ago, only harsher and faster. So the very worlds we would aim for, the closest things to a second Earth within reach, may already be bare airless rock, cooked and scoured, their warmth borrowed from a star that also kills them. We genuinely do not yet know. We cannot confirm whether a single one of them holds breathable air. The honest situation is that our best destinations are a hope, not a promise, and a hope with real reasons to doubt it. Think about what that means for a crossing of thousands of years. You seal your town into its ship, you launch it into the dark, and the generations live and die on the way, all of them trusting that the world at the far end will be worth arriving at. And there is a real chance that when their distant descendants finally arrive, after all those centuries, what waits is another dead rock, another Mars, another world that lost its heir to its own star a long time before anyone set out. The destination might already be a grave. There is a deeper reason the nearest worlds are so hostile, and it comes straight from the kind of star they orbit. A red dwarf is so dim and cool that for a planet to be warm enough for liquid water at all, it has to huddle in very close, far closer than Earth sits to the Sun, and a world that close gets gripped by its star's gravity and held still, so that one face is locked toward the star forever and the other face is away forever. That is called tidal locking, and it is almost certainly the fate of these nearby worlds. One side bakes in endless red daylight, the other freezes in endless night. Any air or water tends to flee the burning day side and freeze out on the frozen night side, leaving a thin habitable ring around the edge, if anything survives at all. A world like that is not a second Earth. It is a planet split into a permanent furnace and a permanent freezer with a sliver of twilight between. And yet these are the worlds we keep looking at, and there is a reason for that worth understanding. Red dwarfs are by far the most common stars in the galaxy, far outnumbering stars like the Sun, and they live almost unimaginably long, which makes them the obvious place to search and the obvious place to aim. So the cruel situation is that the most available real estate in the universe, the most common and longest lasting stars, comes with the harshest landlords, stars that flare and strip and lock their worlds. The galaxy is generous with planets and stingy with good ones. There is one more piece of the distance problem that almost everyone forgets, and it doubles the difficulty of the whole crossing. Getting up to speed is only half the trip. You also have to stop. A ship that accelerates for years to reach a serious fraction of the speed of light then has to spend just as much effort slowing back down at the far end, or it simply tears through the destination system in a blur and flies on into the empty dark beyond, having crossed all those light years only to miss. Stopping costs as much energy as starting, which means the real fuel bill for a true crossing is far worse than just the price of leaving. You are not paying to go fast. You are paying to go fast and then to undo every bit of that speed at the other end, with no star or planet to help you brake until you are already there. Stack all of it together and the picture is sobering. The nearest worlds are thousands of years away at our real speeds. They orbit stars that may have already stripped them bare. Those that survive are likely split into furnace and freezer, and even reaching one means paying twice over, once to leave and once to arrive. None of it is impossible. All of it is harder than the dream admits, and we still have not asked what the crossing itself, the long middle of the trip through supposedly empty space, would do to the ship and the people in it. It is worth being honest about why we are stuck at such crawling speeds, because it is not a small gap we are about to close. Every ship we have ever flown is pushed by throwing mass out the back, and to go faster you must carry more fuel, but more fuel is more mass to push, which needs still more fuel, a spiral that defeats you long before you approach the speed of light. Our fastest craft reach a few tens of kilometers a second, and the probe that holds the record managed about 200, only by falling close to the Sun and being flung. The speeds that would shrink an interstellar crossing from millennia to mere centuries, a serious fraction of light speed, would need engines we do not have, drawing on nuclear fusion or even antimatter, ideas that live on paper and in small experiments and nowhere near a working ship. So when I quote thousands of years for a crossing, I am not being pessimistic. I am quoting the real speeds we can actually reach. The faster ship is a hope, like the habitable world at the far end, and like that world, it is not yet ours. Look hard at the real candidates, because the closer we look, the more the hope thins. Proxima Centauri b, the nearest of all, sits so close to its flaring red star that it is almost certainly locked face on, and we have watched that star erupt with flares strong enough to bathe the planet in radiation that would shred an unprotected atmosphere over time. Around the TRAPPIST-1 star, the worlds in the habitable zone are studied harder than any other planets beyond our own, and the careful reading so far is that the inner ones have probably already lost their heir to the star, while for the outer ones we simply cannot yet tell. So even our very best, most scrutinized destinations come back with the same answer over and over. Maybe, possibly, we cannot confirm a single breathable atmosphere anywhere beyond our own solar system. You would be betting the survival of everyone aboard on a world you could not promise was alive until your descendants arrived, thousands of years too late to change course. And think for a moment about the cruelty of arriving to find it dead. The generations cross in good faith, tending the ship, raising children toward a promised world, and then the descendants of the people who launched finally slow into the target system after thousands of years and look down on another airless rock, another Mars, a planet that lost its heir to its flaring star long before anyone set out. There is no second destination within reach, no fuel to cross to another star, no way home. They would have spent everything, dozens of lifetimes, the whole inheritance of the ship, to reach a grave. That is the gamble hidden inside every interstellar ark we could actually build today. You commit the lives of people not yet born to a world you cannot confirm is alive, and you do not learn the answer until it is far too late to choose differently. So the worlds are far, far further than the dream admits, and the most reachable of them may be dead on arrival. But suppose the ship holds and the crossing is survivable. What is actually out there in all that distance, in the space we think of as empty? Because that space is not empty at all, and at the speeds a real crossing needs, the dark itself starts to bite. Interstellar space is not empty. That is the first thing to understand, because almost everyone pictures the space between the stars as a perfect, harmless vacuum, an endless nothing you could coast through forever without touching a thing. The truth is that the dark between the stars is thinly filled with a haze of gas and a scattering of dust, and at the speeds a real crossing would need, that thin filling turns into a weapon. Start with the gas. Drifting between the stars is a sparse fog of hydrogen and helium, on average only about one atom in every cubic centimetre of space. That is almost nothing, a near perfect emptiness by any everyday measure. Sit still in it and it would never harm you, but a ship trying to cross to another star in any reasonable time has to move fast, a serious fraction of the speed of light, and at those speeds the ship slams into those atoms one after another, above about a tenth of the speed of light. Each of those harmless atoms hits the front of the ship like a bullet of radiation. The thin gas becomes a steady, blazing sleet of hard particles against the bow, the kind of radiation that tears through matter and through living cells, and no thin wall fully stops it. Then there is the dust. Scattered through that same space are tiny grains, far apart, most of them smaller than anything you could see. At a slow pace they are harmless. At a fraction of the speed of light, each grain becomes a tiny hammer blow, a hypervelocity impact that blasts a small crater into the leading edge of the ship and erodes it strike after strike across years and light years of travel. A single grain is nothing. The endless rain of them, over a crossing of thousands of years, slowly grinds away the face the ship turns to its direction of travel. And laced through all of it are the galactic cosmic rays, the heavy, fast particles that fill the whole of deep space, flung out by distant dying stars and violent events across the galaxy. These are the same particles that already make long human spaceflight so dangerous close to home, and out between the stars there is no shelter from them anywhere, no magnetic field, no thick atmosphere, nothing but whatever the ship can wrap around its crew. For the entire crossing, everybody aboard, is being quietly bombarded, its cells damaged a little more each year, with no relief and no rescue within years of travel in any direction. So the dark is not a calm road. It is a long, grinding gauntlet of radiation and erosion, and here is the cruel twist that makes it so hard to escape. The faster you go to shorten the crossing and the years of exposure, the harder the gas and dust hit, because the violence of each impact climbs steeply with speed. The slower you go to soften those impacts, the longer the crossing lasts, and the more total years your crew spends being bombarded by cosmic rays the whole way. There is no clean way out of that trade. You can choose a short, fierce crossing or a long, grinding one, but the dark takes its price either way. I want to be honest that clever engineering could blunt some of this. A thick shield of material across the bow could absorb much of the sleet, though every bit of shielding is more mass to push and protect. A slower speed eases the impacts at the cost of time. None of it makes the crossing safe. It only changes which danger you are choosing to live with. The space between the stars, the part we imagine as the easy, empty middle of the trip, turns out to be one more thing actively trying to wear the ship and the people inside it down. The radiation out there does a particular kind of harm, and it is worth being precise about it, because it is the danger that never lets up. Those galactic cosmic rays are not gentle light, they are heavy atomic nuclei, moving at almost the speed of light, and when one passes through a human body it tears a track of damage through whatever it hits, breaking the delicate molecules that cells are built from, including the strands that carry the instructions for life itself. A body can repair a little of this. It cannot keep up with a constant rain of it across years and centuries. Over a long enough exposure, the damage accumulates into raised cancer risk, and quite possibly harm to the brain and nervous system, a slow degrading of the very minds the ship depends on to keep itself alive. And there is a nasty trap in trying to shield against it. You might think you simply wrap the crew in a thick enough wall and the problem goes away, but when one of these fast, heavy particles slams into a shield, it does not always just stop. It can shatter, throwing off a spray of lighter particles that come through the other side, so that a thin or poorly chosen shield can actually make the radiation inside worse than no shield at all. To truly block it, you need a great deal of mass, and every bit of mass is more weight to accelerate up to speed and then slow back down, feeding straight back into the fuel problem we just talked about. The protection you want is the very thing that makes the ship harder to move. Then there is the silence of being unreachable, which is its own quiet danger. Once the ship is deep in the crossing, there is no steering it from home, because a message takes years to arrive and years to answer, and grows only slower as the gap widens. If something goes wrong, there is no expert back on Earth who can talk the crew through it in time, no instructions that arrive before the crisis is over. The ship is on its own in the most complete way anything has ever been on its own, separated from all help by years of crawling light. And if the worst happens, if a critical system fails in the deep middle of the void with no world within reach, there is no rescue, not slow rescue, not late rescue, no rescue at all. The dark does not send help. So the space between the stars, the part we picture as the restful, empty middle of the trip, is in truth a long exposure to a danger that erodes both the ship and the people, with no shelter that does not cost dearly, no guidance from home, and no rescue if it goes wrong. It is survivable in principle with enough mass and enough care, but survivable is doing a lot of quiet work in that sentence. And once you have accepted all of it, the loneliness of the crossing raises the oldest question we have about the dark, the one we turn to next. In all that emptiness, is there truly no one else? There is one genuine gift hidden in going fast, and it is worth naming because it is real, even if we cannot yet claim it. When anything moves at close to the speed of light, time itself runs slower for it, so a crew travelling fast enough would age less than the centuries ticking by outside, and a crossing that takes thousands of years as measured from home might feel like only years to the people aboard. In principle, that could turn an impossible voyage into a survivable one, the travellers stepping out barely older, at a world thousands of years away. But the gift comes only at speeds we cannot reach, the same serious fraction of light speed that turns the interstellar gas into a sleet of radiation against the bow. So the one effect that could rescue the crossing is locked behind the very speeds that make the crossing deadly, and behind engines we do not have. Slow enough to survive the dust, and the centuries pass in full, fast enough to skip the centuries, and the dark itself becomes a furnace. The universe charges for every shortcut, and this one is no exception. It is worth pausing on what the hull actually is to the people inside it, because it is the same thin barrier we keep meeting in every form. On one side, a fragile warmth, air and water and bodies and light. On the other, a cold and airless dark that would empty a human body in seconds. A few centimeters of wall is the whole of the difference between the living world inside and the killing nothing outside, and that wall has to hold unbroken for thousands of years against radiation and dust and the slow fatigue of metal, with no dock to limp into for repairs. A breach that would be an emergency on a station near Earth, survivable because help is minutes away, is simply the end out here, where help is years away or does not exist at all. The people aboard would live their whole lives, every one of them, pressed up against that thin line between warmth and the void, never able to step outside it, never able to forget it is there. It is the same seal a settler on a dead world lives behind, carried out into a dark with no world beneath it at all. And those people would know nothing else. A child born in the deep middle of the crossing opens its eyes to metal corridors and grow lights and the hum of machines, and that is the entire world it will ever have. No sky, no horizon, no ground, no weather, no sea, no open air, none of the things every human who ever lived took for granted. Only the inside of a machine in the dark beyond the windows. They would be born in the warmth we carried, live their whole lives inside it, and die having never once stood on a world. That is what surviving the death of Earth would actually mean for almost everyone who ever did it. Not a new world under an open sky, but a life lived entirely inside the fire we carried, in the dark between the places. And the erosion is not abstract. It leaves a mark you could see. Over a crossing of thousands of years, the steady rain of gas and dust against the leading face of the ship would slowly grind it down, pitting and thinning the very surface that shields everyone behind it. The front of the ship would wear like a stone in a river, except the river runs for centuries and never lets up, so the ship has to be built thick enough at the bow to be eaten away for an age and still hold, carrying extra hull purely to be sacrificed to the dark, millimetre by millimetre, the whole way across. It is one more weight to haul and one more thing to watch, the slow death of the ship's own face against a sky that looks to the eye completely empty. And across all that distance and all that danger, a natural question rises, maybe the oldest one we have about the dark. Are we alone out there? In all that space we would be crossing, is there anyone else? Another ship, another world already settled, anyone at all who might meet us, or help us, or simply prove we were never the only ones? The answer, so far as we can tell, is not the one we hope for. So far as we can tell, we would cross alone. That is the plain and slightly chilling answer, and it rests on a real and growing body of evidence, not just a feeling. In the last few decades, we have found and confirmed more than 5,000 planets orbiting other stars, real worlds, around real suns, scattered across our corner of the galaxy. We have learnt that planets are common, that most stars have them, that worlds roughly the size of Earth are everywhere we look. The galaxy is full of planets, and across all of that searching, listening as carefully as our instruments allow for any sign that someone else is out there, we have heard nothing. Nothing. No signal that bears the mark of technology. No pulse of radio that could only come from a machine. No light from an engine. No structure around a distant star. No answer of any kind to the silence we have been straining against. Out of a sky crowded with worlds, not one of them has so far given us a single confirmed sign that anyone is home. The planets are there in their thousands. The voices are not. We do not know why, and I am not going to pretend we do, because this is one of the genuine open questions of all of science. Maybe life itself is rare, a fluke that almost never catches. Maybe life is common but intelligence is not. Maybe civilizations arise often and then destroy themselves young, before they can ever reach across the dark. Maybe they are simply too far away, and their signals too faint to have reached us yet. Maybe, for reasons we cannot guess, they stay silent on purpose. Each of those answers points at a very different universe, and we cannot yet tell which one we live in. The silence is real, its meaning is not settled. But hold the practical fact, because for a fleeing humanity it is what matters, whatever the reason behind it. There is no one we know of to run to, no friendly world already settled and waiting to take us in, no refuge built by another hand, no rescue that comes when the ship is failing and the warmth is running low. If we go out into the dark, we go into a silence that, so far as everything we can measure tells us, is total. The crossing is not just long and dangerous, it is lonely in the deepest possible sense, a journey across an ocean with no other ships on it, toward a shore no one has lit a fire on. I find this the quietest and heaviest part of the whole question, and I want to sit with it for a second. We imagine the future of our species as a great spreading outward, joining a crowded galaxy of others. Everything we can actually see says the opposite. We would be carrying the only warmth, the only life, the only minds we have ever confirmed exist anywhere, out into a dark that has so far answered every call with silence. That is a strange weight to put on one fragile ship. Not just our survival, but possibly the survival of the only spark of life there is. And here is where the silence sharpens into a question I want to leave open for you, because reasonable people genuinely split on it. Does that silence mean we really are alone, the first and perhaps the only ones? Or does it mean something darker, that the sky is quiet because everyone else who ever tried has already fallen silent, that the dark is not empty but full of the places where others failed? I have my leanings, and I will not force them on you, because this is one of the few honest places to disagree. Sit with it. There is a way of framing this silence that makes it sharper and a little more frightening, and it is worth laying out plainly. If the galaxy is as old and as full of worlds as it appears, then somewhere in the long story that leads from lifeless rock to a civilization crossing the stars, there must be a step that almost nothing gets past. Some barrier, some filter that stops nearly every world before it ever fills the sky with signals. The unsettling part is that we do not know where that barrier sits. It might be behind us, an early step so unlikely that life almost never even begins, in which case we are rare survivors and the road ahead is open. Or it might be ahead of us, a later step that destroys civilizations before they can spread, in which case the silence is a warning and the empty sky is full of the places where others already failed. We cannot yet tell which, and the stakes of that question could not be higher, because one answer says we are lucky and the other says we are next. It helps to be specific about what we have looked for and not found, because the silence is not only about radio signals. A civilization truly able to spread across the stars would be hard to hide. It might send out self-replicating craft that spread from world to world, filling the galaxy in a span far shorter than the galaxy's age. It might build enormous structures around its stars to capture their energy, structures that would glow with waste heat in a way we could detect. We have looked for the signs of such things, the engines, the structures, the heat, the probes, that should already be here if anyone had ever set out. And we have found none of it. No machines drifting through our own solar system, no stars wrapped in alien engineering, no fleets, no beacons, no trace. So far as we can measure, no one has ever passed this way, and no one is calling. I keep coming back to what that means for the warmth we have been following all night. If the silence really is what it looks like, then the small fragile fire we carry, the life and the warmth aboard one ship, might be the only one there is, the single confirmed flame in a universe of dark and silent worlds. That changes the weight of the whole question. Surviving stops being only about us. It becomes about whether the one spark of life anyone has ever confirmed exists gets carried forward or goes out unwitnessed in the dark. There is no one out there, so far as we can tell, to carry it for us, and no one to notice if we drop it. That is the loneliness a fleeing humanity would actually face, not just distance from home, but the real possibility of being the only ones, the only warmth, in all that emptiness. Whether you find that crushing or strangely magnificent is, I think, a genuine fork in the road, and one of the few places I am happy to leave you to choose for yourself. But alone or not, the dark holds one thing that does not care which, the enemy I asked you to keep hold of, the one waiting at the end of every plan. It is time, finally, to turn and face it directly. There is also a quieter possibility, one that flips the loneliness on its head, and the honest thing is to hold it alongside the rest. Maybe the sky is silent because we are early. The universe is still young, only 14 billion years into a life that runs for trillions, and the long-lived red dwarf stars that may be the best homes for life will keep shining and warming their worlds for far longer than the sun ever will. On that view, the great age of life in the universe is not behind us or even around us. It is mostly still to come, and we may simply be among the first to arrive, opening our eyes before most of the guests. If that is true, then the silence is not a graveyard at all. It is an empty hall before the party, and we are early enough that no one else has shown up yet. It does not change the practical fact that there is no one to meet us tonight, but it changes what the silence might mean, and it is one more place where the same data points two very different ways. And there is a harder truth folded into the loneliness, which is that even if someone were out there, we could not really meet them. The distances that make the crossing take thousands of years make a conversation almost meaningless. Send a greeting to a world 40 light years away, and the answer, if there is one, comes 80 years later, long after the sender is gone. Send a ship and it arrives thousands of years on, to a civilization that may have risen and fallen entirely in the time it took to cross. So even a galaxy quietly full of life would still feel, to any one of its members, almost completely empty, each spark separated from the next by gulfs of space and time too wide for anything like contact. The silence we hear may not only be the silence of absence, it may be the silence of distance, every voice too far and too slow to ever truly reach another. Either way, a fleeing humanity would cross alone and arrive, if it arrived, to no welcome. Whatever the silence finally means, it changes what the warmth in the hull would be. If we are truly the only ones, then that small-made fire aboard one ship is not just our survival, it is the survival of the only life and the only minds that we have ever confirmed exist at all, anywhere. Drop it, and so far as anyone can tell, the universe goes back to having no warmth of that kind in it whatsoever, no one left to know it was ever here. That is a weight I find hard to put down once I have picked it up, not just a species trying to outlive its world, but possibly the single spark of awareness in all the dark, trying to carry itself a little further before the cold takes it. Alone or not though, there is one thing none of it escapes. Whether we cross with company or in total solitude, whether the worlds at the far end are alive or dead, there is an enemy waiting that I told you to hold on to a while ago, the one no ship outruns. It is finally time to face it. because everything we have talked about so far, the ship, the distance, the dark, the loneliness, is survivable, at least in principle. What comes next is not. Here is the enemy I told you to hold. It is time. Not the time a crossing takes, not the years a crew spends in the dark, but a deeper kind of time, the slow dying of the universe itself. Because here is the thing no ship can ever get around, the fact that sits underneath every plan we could possibly make. The stars are going out, and one day there will be no new ones ever again. Let me say plainly what that means, because it is easy to hear and hard to truly take in. Stars are not permanent, and just as importantly, the ability to make new ones is not permanent either. Stars form when clouds of gas collapse and ignite, and the universe has only so much of that gas to spend. Across the whole universe, the rate at which new stars are being born has been falling for billions of years already, as the raw material gets used up and locked away. Our own sun has a few billion years left, which feels like forever, but it is a candle compared to what comes after, and even the longest burning stars are still burning toward an end. The stars that last the longest are not the bright ones. They are the small, dim, slow-burning red dwarfs, the same kind of star that holds those nearby planets we talked about. A big, bright star like a blue giant burns through its fuel in a few million years and dies young. A red dwarf sips its fuel so slowly and mixes it so thoroughly that the smallest of them can keep burning for something like 10 trillion years. 10 trillion, that is 1,000 times the entire age the universe has reached so far. These tiny red embers are the marathon runners of the universe, the last stars that will still be shining long after every bright star is gone. But here is the part that lands like a stone. Even they go out. Even the longest burning star that exists finishes its fuel in the end, and once the gas to make new stars is gone, no new star ever forms to replace them. So there is a last one. Somewhere around 100 trillion years from now, the final star anywhere in the universe will use up the last of its fuel and fade, and when it does, the lights go out for good. Not for a night, not for an age, for the rest of time. After that moment, there is never another sunrise anywhere, on any world, around any star, because there are no more stars to rise. Now feel how that lands on everything we have said so far. We talked about crossing the dark to reach another star. We talked about moving from a dying world to a living one. All of that quietly assumed there would always be another star to reach, another fire to gather around. But you cannot sail to a star that no longer exists. You cannot warm your ship at a sun that has gone cold. Every escape plan we have, every hope of moving on to somewhere new, runs into the same wall in the end, that the supply of stars is finite, and it is running down, star by star, toward a final darkness. This is the thing no ship outruns. You can build the perfect sealed world. You can solve the distance, survive the dark, endure the loneliness, and none of it matters against this, because moving from place to place was never the real problem. The places themselves are going out. The distance between the stars was never going to be what beat us. The dying of the stars was, and behind it, the plainest enemy there is, time. And the warmth we have been carrying this whole way, the made heat in the hull, the fire we light against the cold, suddenly looks very different. On Earth, the sun gave it to us for free. In the ship, we made our own. At a new star, we might have borrowed another's for a while, but when the stars themselves are gone, there is no fresh source of warmth left anywhere to borrow, only the slowly cooling leftovers of suns that have already died. We would be down to the embers. Here is a fact that makes the dying of the stars feel less like a distant abstraction and more like something already underway. The universe has very probably already made most of the stars it will ever make. The great age of star birth, when galaxies blazed with new suns lighting up by the billion, peaked long ago, several billion years in the past, and the rate of new star formation has been falling ever since. We are not at the dawn of the universe of stars. We are past its noon, on the long, slow afternoon side, when fewer and fewer new fires are being lit and more of the gas is locked away in stars that will never give it back. The lights are not all on, with more to come. Most of the lights that will ever be lit are already burning and slowly using themselves up. Try to hold the time scale, because it is the thing that breaks the comfort of those red dwarf marathon runners. The universe right now is about 14 billion years old. The last stars will not finish burning until something like 100 trillion years have passed. That is roughly 7,000 times the entire age of everything so far. If you compressed the whole history of the universe up to this moment into a single day, the age of starlight would not even be the first few seconds of it. It is an almost unthinkable stretch of future, and a stubborn survivor really could last across much of it. But here is the part the size of the number cannot soften. However long it runs, it ends. There is a last one. Sit with that phrase for a moment, because it is one of the strangest in all of physics. The last star, somewhere out in that almost endless future, one final red ember, the very last star anywhere in the universe, will use up the last of its fuel and fade from red to dark. And when it does, that is the last sunrise that will ever happen on any world around any sun for the rest of time. Not the last for a while, the last full stop. After that, the universe is a place where the very idea of a star is a thing of the deep past, a kind of fire that used to exist and never will again, because the fuel to make them is spent and gone. And that is the wall every escape runs into. The reason none of the cleverness of the first half of this video finally saves us. We imagined building the perfect ship and crossing to a new star when our own died. We imagined moving on, again and again, outrunning the death of any one sun by finding another. But that whole strategy quietly depends on there always being another star to find, and there will not always be. The supply is finite, and it is draining, and at the end of it the sky is simply dark. You cannot relocate to a star that no longer burns. You cannot warm a ship at a fire that has gone out. When the stars are gone, the easy answer, just go somewhere new, is gone with them. What is left is only the slowly cooling wreckage of suns that already died, and the question of whether anything could wring a living from that. There is something worth sitting with in the fact that we are alive now, this early, while the sky is still full of fire. We happen to exist in the bright era of the universe, the stretch when stars blaze in their billions and the night sky is crowded with them. A civilization born 100 trillion years from now, around one of the last red dwarfs, would look up into a sky almost empty of stars, the other galaxies long since carried beyond reach, and would have no way of even knowing that the universe was once ablaze with light. The evidence would be gone, swept away by the same expansion and decay we have been tracing. So in a strange way, the warmth around us now is not just our inheritance, it is a privilege of timing, a window of brightness we happen to have been born inside. The fire is still burning everywhere we look. We are simply early enough to see it, and the whole of this video is about watching, in fast forward, that fire go out. Our own galaxy shows the slow turn toward darkness already beginning. The Milky Way still makes new stars, but slowly, and the gas it uses to make them is finite and dwindling, locked away little by little into stars that will never give it all back. In time, our galaxy too will run low on the raw material for new suns. Its bright young blue stars will die without replacements, and it will redden and dim into a quiet collection of long-lived embers. Every galaxy is on the same road, burning through a one-time inheritance of star-making gas that nothing refills. When people imagine the far future as more of the same, more stars, more worlds, endlessly, they are imagining something the universe simply does not do. The gas was laid down early, and it is being spent and there is no second delivery coming. What we see around us is a one-time blaze, and we are watching it from somewhere in the middle, mistaking a fire for a fixture. You might wonder whether a survivor could simply keep hopping to ever longer lived stars, always finding a fresh red dwarf to outlast the last. And the answer is that even that road has an end. Red dwarfs are common, and they burn for trillions of years, so the strategy buys an enormous amount of time. But they are still finite in number, and they are still burning, every one of them, toward the same exhaustion. Move from one to the next as each fades, and you are not escaping the ending, only walking slowly toward it across the longest possible bridge, putting out one foot as the boards behind you fall away. Eventually you arrive at the last red dwarf there is, warm yourself at it for its trillions of years, and watch it too go dark, with nowhere left to step. The hopping does not change the destination, it only stretches the walk, and at the end of even that longest walk, the sky is empty of stars, and the strategy that worked for 100 trillion years finally has nothing left to work with. I keep circling back to that phrase, the last sunrise, because of everything in this video, it is the one that reaches me most. Every sunrise you have ever seen, every dawn on every world that ever held life, has been the same physical event, a star pouring out the warmth that life feeds on. And there is a last one coming, not a metaphor, an actual final time that any star anywhere lifts its warmth over any horizon. After it, the universe still exists, still has its dead stars and its black holes and its long cold afterlife, but it never has that again, the simple thing we have had every single day without once earning it. We are living inside the era of sunrises, near its beginning, with almost all of them still to come and yet a definite end to the whole supply. That is the warmth this video is really about, and the slow loss of it is the story underneath every section, which raises the question that carries us into the long dark ahead. If the stars run out, if there is no new fire to be lit anywhere in the universe, then what could anything possibly live on after that? When the last star fades, is that simply the end of the story? Or is there still something out there in the dark, some last warmth to be scraped together by anyone stubborn enough to still be alive? As it happens, when the stars go out, the universe is not quite empty, it is full of their corpses, and for a while, those still hold a little heat. When the last star goes out, the universe is not empty, it is full of corpses, and a corpse for a long time still holds a little heat. This is the era that comes after the stars, and a stubborn survivor could last in it for a span that makes everything before it look like an eye blink. The trick is to stop looking for living stars and start scavenging the dead ones. The dark universe is littered with the remnants of stars that have already died. The most useful of these are the white dwarfs, the burnt-out cores of stars like our own sun, left behind after the outer layers blow away. A white dwarf is a strange object, a ball of dead star matter about the size of a planet but as heavy as a sun. And crucially, it is still warm. It no longer burns, but it glows with leftover heat, and it cools so slowly that it can stay warm for billions of years, radiating the last of its old fire into the dark. Scattered among them are the neutron stars, even denser corpses, and the cold failed stars that never quite caught fire at all. A civilization that survived the death of the stars could move among these embers, gathering around each fading white dwarf in turn, drawing off the last of its warmth, and moving on to the next when it finally goes cold. That is survival of a kind, and it could last almost unimaginably long. We are talking about a stretch of time so immense that the numbers stop meaning anything in the ordinary way. The era of these cooling stellar corpses runs not for billions of years, but for a length of time written as a 1 followed by dozens of zeros, far longer than the entire age of starlight that came before it. A patient, stubborn survivor, hoarding warmth from one dead star after another, could in principle keep going through all of it, an almost endless twilight of scavenging among the dead. We stayed, such a survivor might still say, huddled around the corpse of a sun that died 1 trillion years ago. We are still here. But there is a deeper clock underneath even this, and it is one of the strangest ideas in all of physics. The matter itself may not last. Everything you are made of, everything the dead stars are made of, is built from tiny particles, and among the most basic of these is the proton, one of the building blocks at the heart of every atom. We have always assumed protons are permanent, that they simply last. But some of our best theories predict that even the proton slowly decays, falling apart on a timescale so long it is hard to write, around a 1 followed by 34 zeros in years, or longer still. If that is true, then over those almost endless spans, the atoms themselves begin to crumble. The dead stars, the planets, the very material a survivor is made of, all of it would slowly dissolve at the smallest scale, the matter quietly coming apart out from under everything. I have to be honest about the uncertainty here, because it is real and it matters. We do not actually know whether protons decay at all. We have built enormous detectors and watched huge amounts of matter for any sign of a proton falling apart, and so far we have seen none, which only tells us that if it happens even more slowly than we first guessed. So this particular clock might run far longer than we think, or it might not tick at all. But if it does, then there is a limit even on the embers, a point where there are no more dead stars to scavenge, because the dead stars themselves have crumbled away into a thin haze of particles. So picture the universe in that long darkening. No bright stars anywhere, the sky truly black. Scattered through it, the cooling corpses of dead suns, their faint warmth winking out one by one as the ages pass, and a survivor, if one is left, moving between them, gathering the last heat, watching even the embers fade, while underneath it all the matter slowly comes undone. The fire of the universe did not just go out, the hearth it burned in is crumbling too. There is a haunting detail about those cooling white dwarfs, the dead stars a survivor would scavenge, and it tells you how young the universe still is. A white dwarf cools so slowly that to fade completely, to become a truly cold, dark, dead cinder, takes far longer than the universe has yet existed, which means that in all of time so far, not a single white dwarf anywhere has finished cooling. The fully dead version of a dead star, the cold black cinder it eventually becomes, does not exist yet anywhere in the universe, because there has not been enough time for even one to get there. Every dead star out there is still faintly warm, still radiating the last of its old fire, and will keep doing so for billions of years more. The embers a far future survivor would gather around have not even properly cooled yet. That is how early in the long story we still are. So a survival strategy in that era starts to take shape, and it is a strategy of patient scavenging. You do not look for new fire, because there is none. You find a dead star still holding its warmth. You settle in close, and you draw off that leftover heat for as long as it lasts, which might be billions of years for a single white dwarf. When it finally fades toward cold, you move on to another that has not cooled as far, and then another, working your way across a darkening galaxy of cinders, always seeking the next one with a little warmth left in it. It is a thin and careful way to live, hoarding the leftovers of suns that died ages ago, but it could stretch existence across spans that dwarf the entire age of starlight. Underneath even that, though, runs the deepest clock of all, and it threatens not just the fire but the firewood. Everything is built from atoms, and atoms are built from particles, and one of the most basic of those, the proton, may not be permanent. If our deeper theories are right, a proton very slowly falls apart on a time scale so long it is almost a joke to write, far longer than the age of the stars or even the long era of the dead stars. We have hunted for this, deep underground in enormous tanks of water watched by sensitive detectors. We have stared at huge numbers of protons, waiting for even one to break, and we have not caught a single one yet, which tells us only that if it happens even more slowly than we feared. But if it happens at all, then over those endless spans the dead stars themselves crumble, the atoms unraveling, the very stuff a survivor and its ship are made of slowly coming apart into a thin haze. So the long darkening has two endings stacked inside it. First, the warmth runs out as the last embers cool toward dark. Then, if the protons truly decay, even the cold cinders dissolve, and the matter that held the warmth is gone too. There is no firewood and no hearth, only a thinning fog of particles spreading through an ever colder dark. And yet, even then, the universe is not quite finished handing out last chances, because there is one kind of object left that outlasts the dead stars and may outlast even the decay of matter itself. The black holes are still there, and strange as it sounds, they still have warmth to give. The dead stars come in more than one kind, and a true survivor would learn to use each. White dwarfs are the most common and the most useful, the warm cinders of ordinary suns. But there are also the neutron stars, the collapsed hearts of larger stars, so dense that a sugar cube of their matter would weigh as much as a mountain, spinning and slowly cooling in the dark. And there are the brown dwarfs, the failed stars that never grew massive enough to truly ignite, holding a faint warmth of their own. None of these is a fire in the way a living star is a fire. They are all leftovers, holding heat they are slowly losing, and will never replace. A civilization in that era would be less like settlers and more like scavengers picking through a battlefield after the war, taking what warmth still clings to the fallen, knowing none of it will ever be renewed. It is survival, but it is survival with the lights already out, lit only by the fading glow of things that died long ago. There is even a strange faint glimmer of hope in this era, and honesty means including it. A cooling white dwarf, for a stretch of its long fade, glows with a warmth not so different from a small sun, and a world orbiting close enough to one could in principle catch that warmth, hold liquid water, perhaps even wear something like a blue sky for 1 billion years or more. So life clinging to the embers is not pure fantasy. For a long window, a careful civilization might gather around a dead star almost the way we gather around a living one, warming itself at a fire that is already going out but has not yet gone cold. The catch is in those last words. It is already going out. Every white dwarf is cooling, every year a little dimmer, and the warmth it offers is a fixed inheritance with nothing adding to it. You are not living beside a fire, you are living beside a coal, and watching it darken. The hardest thing to hold about that era is that nothing in it is ever made new. In the universe we know, stars die but new ones are born, matter is recycled, fresh fire is constantly lit from the ashes of the old. In the long darkening, that engine has stopped. Every dead star is a fixed inheritance, cooling and never reheating. Every scrap of warmth is a withdrawal from an account that takes no deposits. A civilization there would live entirely on savings, with no income ever again, watching the balance fall no matter how carefully it's spent. That is a different kind of existence from anything we know, where there is always a next harvest, a next generation of stars, a next morning. In the long dark, there is only less, then less, then less, forever. Survival becomes the art of falling as slowly as possible. It is worth saying plainly how strange this future would feel to anyone living in it. A sky with no stars in it, only black, with here and there the faint glow of a cooling cinder that was once a sun. No dawn, no daylight, no seasons, no living star anywhere to be seen. A survivor there would know warmth only as a thing measured and rationed, drawn from a dead object that is slowly going cold, with the certain knowledge that when it finishes cooling there will be no other. We are so used to a sky full of fire that an empty one is almost impossible to picture, but that emptiness is where most of the future actually lives, and any survival worth the name would have to be built to endure it, in a dark with no morning ever coming. which leaves one last question for the very end of things. When even the dead stars are gone, when the embers have cooled and the matter has frayed, is there truly nothing left in the universe to live on? Or is there one last source of warmth, one final fire, in the strangest objects of all? As it turns out, the very last era of the universe belongs to the only thing still standing when everything else has fallen: the black holes. In the final eras of the universe, the only things left standing are black holes. Long after the last star has died, long after even the dead stars have crumbled away, the black holes remain, the densest and most stubborn objects there are, the last great structures in a universe of thinning dark. And here is the surprise that almost no one expects. Even they are not permanent. Even a black hole, the thing we think of as the ultimate trap from which nothing escapes, slowly dies. We tend to imagine black holes as forever, bottomless pits that only ever grow. But they leak. Through a subtle effect at their very edge, a black hole slowly radiates a faint trickle of energy out into the dark, and over time that trickle carries the black hole away, gram by gram, shrinking it across spans of time that dwarf everything we have discussed so far. A black hole is no permanent pit. It is the slowest burning fire in the universe, leaking its enormous store of energy out into the cold over almost incomprehensible ages. And to a survivor, that faint leak is the last warmth in existence. When there are no stars, no embers, nothing else giving off any heat at all, a black hole quietly radiating into the dark is the only source of energy left. So you can picture the very last act of life in the universe as a gathering around these final objects, a civilization huddled at the edge of a slowly evaporating black hole, drawing off its thin trickle of warmth, tending the last fire there will ever be. It is the same trick we started with on Earth: warmth flowing from something hotter to something colder, and a little life wrung out of the difference. Only now the hot thing is a dying black hole, and the cold is the almost perfect cold of an emptying universe. The timescales here break the mind, and that is part of the point. The largest black holes, the supermassive ones that once sat at the hearts of whole galaxies, take something close to a 1, followed by 100 zeros in years, to fully leak away and vanish. That number is so much larger than everything that came before it, that all of the age of stars, all of the long darkening of the dead suns, the entire history of light in the universe, is less than a rounding error beside it. If anything could survive that long, gathered at the last black holes, it would outlast not just the stars but the very afterlife of the stars, by a margin almost beyond counting. But notice the word at the center of all of it: leak, evaporate. A black hole survives by spending itself, and a thing that spends itself eventually runs out. When the last black hole finishes radiating the last of its energy into the dark, it does not leave a remnant, it is simply gone, and with it goes the final source of warmth in the universe. The last fire, the one a final civilization might have gathered around at the very end of time, gutters down to nothing, and then there is nothing left to burn anywhere, ever again. I want to be straight that the physics out here, at the literal end of time, is at the edge of what we understand, and some of the details are genuinely uncertain. We are reasoning from the laws as we best know them, pushed to scales we can never test, but the overall shape of it is robust across everything we know. The universe trends, always and everywhere, towards spreading out, cooling down and running dry, stars to embers, embers to black holes to nothing. The direction never reverses. The way a black hole leaks its warmth is one of the strangest results in all of physics, and it is worth a plain account because it decides the very last chapter of survival. At the edge of a black hole, where its pull is fiercest, the empty dark is not quite as empty as it looks, and through a subtle effect, the black hole slowly radiates a faint glow outward, carrying tiny amounts of its energy away into space. That glow is its warmth, the last usable heat there will ever be, and a black hole gives it off without anything falling in at all. It is, in the most literal sense, a fire that burns by consuming itself, shrinking very slowly as it sheds its energy into the cold. Here is the part that turns everything upside down. The bigger the black hole, the colder it is, and the slower it leaks. The small ones are hotter and die faster. The giant ones, the supermassive black holes that once anchored whole galaxies, are so cold and so slow that they take almost beyond imagining long to fade. So in the final reckoning, the coldest, most lifeless seeming objects in the universe are the very ones that last the longest, the final holdouts against the dark, precisely because they give up their warmth so grudgingly. A survivor at the end of time would gather not at the brightest fire, but at the dimmest and slowest one, because the dim, slow fire is the one that is still there. And the numbers are past all grasping. A large, supermassive black hole takes something like a 1, followed by 100 zeros in years to finish leaking away. Write the age of the universe so far as a single step, and this is a number of steps with 100 zeros after it, a gulf so much larger than everything before it that the entire history of stars and dead stars and crumbling matter is gone in the first flicker of it. If anything at all is still alive at the last black holes, it has outlasted not just the stars but the whole long afterlife of the stars by a margin that makes the word long meaningless. But even this ends, and it ends with a strange final act.
As a black hole leaks away and shrinks, it gets hotter and leaks faster, so the very end is not a slow fade but a quickening, a last acceleration, until the final remnant goes in a burst and the black hole is simply gone. No cinder, no corpse, nothing left behind to gather around. When the last black hole finishes evaporating, the last concentrated thing in the universe is gone, and with it the last source of warmth there will ever be. The final fire does not get handed on, it goes out, and there is nothing to light another.
What remains after that is the thinnest imaginable haze, a few stray particles of light and matter drifting through an enormous dark, spreading ever further apart, growing ever colder, with no structure, no fire, and nothing happening anywhere. That is where survival finally, truly runs out of room. The reason is not that we failed to be clever. There is simply no longer anything left to be clever with. And it brings us to the reason underneath all of it, the single principle that has been quietly writing this whole story from the first star to the last black hole, the reason none of it could ever last forever. There is an even stranger possibility that opens up if the protons do not decay after all, and it stretches the timeline past all reason. If matter is more stable than we fear, then the cold, dead cinders of stars do not crumble away. Instead, over spans so long they make the black hole timescales look quick. The atoms inside them very slowly rearrange, creeping toward the most stable form of matter there is, until whole dead stars turn, over unthinkable ages, into spheres of cold iron. Iron stars, they are sometimes called, the final cold statues of suns, formed over a length of time written as a 1, with hundreds or even more than 1,000 zeros after it. Whether that ever happens depends on questions we cannot answer, and it sits so far in the future that even the evaporation of the black holes might come first. I raise it only to show how strange and how long the deep future runs, and how every one of these almost endless roads still arrives, in the end, at the same cold and silent place. The timescales differ past all meaning. The destination never does, and the very last state of things is almost impossible to picture, because there is so little left to picture. After the final black hole is gone, what remains is a thin drift of stray particles and faint light, spreading through an ever-growing dark, getting further apart and colder with every passing age. Even that faint light loses its strength, stretched out by the endless expansion, until its warmth fades toward nothing. There are no objects, no structures, no hot places and no cold places, only an almost perfectly even, almost perfectly cold emptiness, growing emptier forever. Nothing happens in it, because nothing can, and there is no one to see that nothing happens. That is not a dramatic ending, it is the quietest possible one, a universe that does not explode or collapse but simply runs down, smooths out, and goes still, holding that stillness for an eternity of time, in which time itself has stopped meaning anything. The fire we carried as far as it would go is out, and the dark it burned against has won, not by force, but by patience. So we have followed survival as far as it can possibly go, past the stars, past the dead stars, all the way to the last evaporating black hole. And at every step the same thing has been happening, quietly, underneath the spectacle. The warmth has been running out, which brings us finally to the wall that was underneath the whole question from the very beginning, the real reason none of this can last forever. It is not really about stars, or black holes, or any particular object at all. What it comes down to is the difference that all life runs on, and what happens when that difference is finally, completely spent. The real wall is not running out of places, it is running out of difference. This is the deepest fact in the whole video, and once you see it, the ending stops being a surprise and starts being inevitable. Everything alive, everything that does anything at all, runs on a difference between hot and cold. Let me make that concrete, because it is the heart of it. A fire works because the flame is hot and the air around it is cold, and heat flows from the one to the other. Your body works because it is warmer than the air, and energy flows out of you, and you spend your whole life feeding that flow. A star works because its blazing core sits in the cold of space, and the heat pouring out across that gap is what makes it shine. In every single case, the trick is the same. You need a hot place and a cold place, and you live in the flow of warmth between them. Take away the difference, make everything the same temperature, and the flow stops, and with it stops everything that flow was driving. No difference, no flow. No flow, no life, no thought, no fire. Now look back at the whole story we have told, because it has secretly been one story all along. The bright stars spend their difference fast and die young. The red dwarfs spend it slowly and last for trillions of years. The dead stars hold a leftover difference and cool toward the dark. The black holes hold the very last difference and leak it away over ages. At every stage, the universe has been doing one thing, relentlessly, in the background. It has been spending its differences, smoothing out, cooling the hot places and warming the cold ones, ever so slightly, toward each other. And the end state of that, the place it is all heading, has a name: heat death. Heat death is not fire, and it is nothing violent. Quite the opposite. It is a universe that has finally reached one single temperature everywhere, the same faint cold in every direction, with no hot places left and no cold places left, only a smooth, even, lukewarm nothing. And in that universe, nothing can happen. There is no difference anywhere for warmth to flow across, so no warmth flows, so no work can be done by anyone ever. No fire can be lit, because there is nowhere colder for its heat to go. No thought can be thought, because a thought is a tiny act of work, and work needs a flow, and the flow is gone. That is the true end, not a bang, not a final explosion, but a universe gone perfectly, evenly cold, in which the very possibility of life has quietly ceased to exist. And there is a crueler turn, because the universe does not even let a survivor reach for all the energy that is out there. Space itself is expanding, and that expansion is speeding up, driven by something we call dark energy that we barely understand. What that acceleration does over time is carry distant things away from us faster and faster until they cross a kind of horizon and can never be reached again. Already on the scale of the whole universe, almost every other galaxy is being swept beyond that line. Within something like 100 to 150 billion years, a surviving civilization would find itself sealed inside its own small island of stars, our own local cluster of galaxies, with the entire rest of the universe gone, carried off beyond reach, dark and unreachable forever. All that energy, all those other stars, no longer just far away but permanently cut off. Whatever a civilization could ever use would be only what it could hold within its own shrinking island, a finite store, and no more coming, ever. Now, there is a famous hope here, and I want to give it its due, because it is the one place this whole grim story cracks open a little. Decades ago, a physicist named Freeman Dyson argued that a clever enough civilization might survive forever, even in a cooling universe, by slowing itself down. The idea is beautiful. As the universe cools, you think slower and slower, spend energy more and more sparingly, sleep through long stretches and wake only rarely, stretching a finite store of energy across an endless future by using it ever more thinly, an endless life on a finite fire, simply by burning it slower and slower, without ever quite burning out. It is a wonderful argument, and the trouble is that it may not survive what we have since learned. Because of that accelerating expansion, the universe does not cool toward nothing. It seems to cool toward a floor, a lowest possible temperature it never drops below, set by that very expansion. And if there is a floor, then there is a smallest possible cost for a single thought, a cost that never gets cheaper no matter how long you wait. With only a finite store of energy and a fixed minimum price per thought, the number of thoughts you can ever have is finite. Astronomically, dizzyingly large, but finite. The careful modern answer, argued by physicists pushing Dyson's idea against the accelerating universe, is that a real civilization can only ever have a finite total span, however long. Not forever, just very, very long. There is a single law underneath everything we have watched, and it has a name worth knowing, because it is the closest thing physics has to a law of fate. It is the rule that, left to itself, everything spreads out. Heat flows from hot to cold, and never the other way on its own. Order falls apart into disorder. Differences even out. Physicists measure that spreading out with a quantity called entropy, and the iron rule is that the entropy of the whole universe only ever climbs, never falls. That climb is the deepest reason time even has a direction, why the past is different from the future, why a fire turns wood to ash and never ash back to wood. And it is the same rule that dooms every fire in the end. Because as entropy climbs toward its maximum, the differences that life feeds on are used up until there is nothing left to spend. Heat death is just the name for entropy reaching the top, the universe fully spread out, fully smoothed, with no more downhill anywhere for anything to flow. There is one genuine crack of hope in this, and I want to give it room, because honest people are still arguing it. Some physicists point out that the cost of a single act of thinking is not fixed by nature, and that there may be ways of computing, ways of thinking, that waste almost no energy at all, sliding so gently from one state to the next that they barely spend anything. If a far future mind could think in that nearly costless way, then perhaps a finite store of energy could carry a great deal more thought than the grim arithmetic suggests, stretching a mind's life far past what we calculated. Others go further still and question whether the universe ever truly reaches a perfect dead calm at all, or whether it keeps finding new ways to change. I do not know who is right. This really is the live edge of the question, the place where the honest answer is still being worked out rather than already known. But notice what the accelerating expansion does to even the most hopeful version, because it answers in the end your question about finding other worlds. We asked early on whether we could keep moving from world to world, star to star, staying alive by always finding somewhere new to go. The expansion of space quietly closes that door. Already, almost every galaxy beyond our own small cluster is being carried away from us faster and faster, and within roughly 100 to 150 billion years, everything outside our local island of galaxies will have crossed beyond reach so far and so fast that no ship and no signal could ever catch it. The other worlds do not just become hard to reach, they become impossible to reach, cut off behind a horizon that only grows. So the long-term answer to could we find other planets is the bleakest kind of no. Not only are they distant, in the deep future, almost all of them are gone, swept out of the reachable universe entirely, leaving a survivor sealed in an ever smaller, ever colder island with a fixed and shrinking store of warmth. So the wall is real, and it is made of the most basic physics there is. Energy spreads out, differences die, the reachable universe shrinks. However clever a civilization became, however long it stretched its fire, it would be working against a current that never turns, in a room that only gets smaller and colder. Whether something could think its way to very nearly forever inside that closing room is genuinely open, and I lean toward no while holding it loosely. But very nearly forever is the most anyone is even arguing for. Forever itself is off the table. So let me gather the whole of it, the ship and the worlds and the dark and the dying universe, and give you the plainest answer I can. I should add one honest note of uncertainty about dark energy itself, because it is the thing setting the deadline, and we understand it least of all. We can measure that the expansion of space is speeding up, and we have given the cause a name, but a name is not an explanation, and we genuinely do not know what dark energy truly is. Most of our reckoning assumes it stays constant, an unchanging push built into space itself, and on that assumption the other galaxies wall themselves off, and the cold floor holds, and the future plays out as we have described. But recent measurements have hinted, only hinted, that dark energy might not be perfectly constant, that it could weaken or shift over time, and if it does, the far future could look different in ways we cannot yet pin down. It would not save us from the deeper rule that energy spreads out and differences die, but it is a reminder that the single most important factor in the fate of everything is also the one we understand the least, and that the deep future is written in pencil, not ink. The direction is certain. The exact ending is still being measured. There is one last change to our own sky worth marking, because it is the first step of this great withdrawal, and it is already on its way. Our neighbour galaxy Andromeda is falling toward us, and in a few billion years the two great spirals will collide and merge into a single larger galaxy. After that, the rest of the universe keeps pulling away, until our merged galaxy and its handful of small companions stand alone, one island of stars in an enormous emptiness, with no other galaxy near enough to see. A civilization living then, looking out, would see only their own island, and beyond it nothing, a black and apparently endless void. They would have no way of knowing the universe was ever full of galaxies at all, because the evidence would have receded beyond reach and beyond sight. The truth of the universe, its size, its history, its billions of galaxies, becomes literally unknowable to anyone born late enough. The cold does not only take the warmth, in time it takes even the memory of what the universe used to be. It helps to make the finite store vivid, because numbers this large can fool you into thinking they are the same as endless, and they are not. Imagine a survivor with an almost unimaginable hoard of energy, the entire output of a galaxy gathered and saved, spread across a future with no end. That hoard still runs out, because any amount of energy, however large, divided across endless time, gives less and less per moment, until there is effectively nothing left to spend. And there is a tax on every use, because each time you put energy to work, some of it spreads out into useless waste heat that can never be gathered back. You cannot simply recycle the same warmth forever. Every cycle degrades it a little, pushes it a little further toward the uniform cold, until what is left can do no work at all. That is the quiet machinery of the ending, not a single catastrophe, but a slow, lawful, unstoppable tax on existence itself, collected on every thought and every heartbeat until the account is finally empty. This is also, in the end, why time has a direction at all, which is a strange and lovely thing to realize. The reason you remember the past and not the future, the reason a broken cup never leaps back together, the reason you are born young and grow old, is this same relentless spreading out of energy, this same climb of entropy toward its maximum. The arrow of time and the death of the universe are the same fact seen from two angles. Every moment you experience the forward flow of time, you are riding the very current that is carrying the universe toward its cold and even end. To be alive at all, to think a single thought, is to spend a little of the difference that the universe is running out of. We are not separate from the dying, we are made of it, a brief eddy in the long settling, and the same flow that lets us live is the one that guarantees we cannot do it forever. I want to be fair about how enormous finite can be, because it is easy to hear the word as small, and it is not. The kind of span a careful civilization might wring out of the dying universe is not thousands of years, or millions, or billions. It is a length of time next to which the entire age of the universe so far, every star that has ever burned, every world that has ever lived, is a brief flicker at the very beginning. You could run a civilization for longer than the current age of everything, over and over, an unthinkable number of times, and still not reach the end of what the deep future allows. So when I say the answer is no, that we cannot last forever, I am not saying our time is short. I am saying that even a span this enormous, this far past imagining, is still not endless, and the gap between almost forever and forever is the whole of the difference. We get the almost, we never get the rest. I will leave this one genuinely open, because it is one of the few places the honest answer is still being argued. Some think a clever enough mind might find a way around even this, through ways of computing that cost almost nothing, or because the universe might never quite settle into that perfect dead calm. Others think the wall is absolute. I lean toward the wall, toward the finite, but I hold it loosely, and I think you should too, because here at the very edge of physics, reasonable people genuinely disagree. So after all of it, after the ship and the worlds and the dark and the dying stars and the last black hole and the cold, what is the actual answer? Let me put the whole thing together and say it plainly. So, could we survive until the end of the universe? Here is the whole accounting, laid out plainly, with nothing softened and nothing oversold. We could, in principle, survive the death of Earth. We could build a sealed world and carry our own warmth into the dark, though we cannot do it yet and are nowhere close. We could cross to another star if we were willing to spend thousands of years doing it, and if the world at the far end turned out not to be another dead rock, stripped bare by its own sun. We could endure the radiation and the erosion of the dark between the stars at a price, and we could bear the silence of a sky that, so far as we can tell, holds no one else at all. And then, when the stars themselves began to die, we could scrape by for an almost endless twilight, huddled around the cooling corpses of dead suns, and after them the last leaking warmth of the black holes, stretching survival to a length of time that genuinely beggars the imagination. But not forever. That is the answer, and I am not going to dress it up. The universe itself is running down, spending its differences, smoothing toward one uniform cold in which no warmth flows, and nothing can happen at all. Every fire goes out in the end, because the universe is slowly removing the very possibility of fire. We could stay for so long that the word forever would feel earned, for a span next to which the entire age of the stars is a brief opening act, and it would still, in the end, be finite. The honest answer to surviving until the true end of everything is no. The reason is not any lack of cleverness on our part. The universe simply does not leave the door open that long, for anyone. I want to be careful not to let that land as despair though, because I do not think it is. Look at what the real answer actually is. Not that we are doomed soon, and not that we become immortal among the stars, the two easy stories people usually reach for. The real answer sits between them, and it is stranger and bigger than either. We could last almost unthinkably long. We could carry our warmth past the death of our world, past the death of our sun, past the death of nearly every star that will ever shine, and keep it burning in the dark for ages no human mind can really hold. That is not nothing, that is very nearly everything. It is just not literally everything, because literally everything is not on offer, to us or to anyone. And there is a lesson tucked inside all of this that I keep coming back to, and it is the same one a dead world like Mars teaches, only written across the whole of time. Every escape is borrowed time. The ship, the new star, the scavenged embers, all of it is a way of borrowing a little more existence from a universe that is ultimately going to ask for it back, which means the home that actually works, the living world, and the steady sun that made us and feed us for free right now, is worth more than any escape we could ever build, because it is the one place the warmth still comes without being borrowed. We spend so much imagination on the lifeboats. The thing actually keeping us alive is the ship we were born on, and it is the only one that was ever given to us freely. I want to be careful with the word survival here, at the end, because all night it has quietly been changing shape, and you deserve to see what it finally became. At the start it meant getting off a dying Earth alive, then it meant keeping a sealed town breathing across the dark, then it meant huddling at the embers of dead suns, and finally tending the last leaking warmth of a black hole at the end of time. By the end, survival is not living on a world at all. It is a thinning, slowing, ever more careful guarding of a fire against a cold that always wins in the end. When we ask whether we could survive until the end of the universe, that is the real thing we are asking to keep going. Not gardens and cities and open skies, but the bare flame itself, carried as far into the dark as physics will allow. And the honest verdict on that flame is the one thing I will not soften. It can be carried astonishingly far. It cannot be carried forever. What you make of that gap between astonishingly far and forever is where I have to hand the question back to you, because the facts run out exactly there, and only judgment is left. One person hears all this and feels the weight of an ending that no effort can avoid, and calls the whole project a tragedy, a long brave fight for a cause that was always lost. Another hears the same facts and feels something closer to awe, that a small warm thing born on one fragile world might carry its fire past the death of its sun and nearly to the end of time itself, and calls that a triumph precisely because it was always going to end. Both are looking at the same numbers. They simply weigh them differently. Where I land, if you want it, is on the side of carrying the fire. I think a finite span that runs almost to the end of everything is worth having, worth fighting for, worth the whole enormous effort, and that the certainty of an ending does not empty the in-between of meaning any more than your own life is made worthless by the fact that it ends. The fire is precious because it is rare and because it is brief, not in spite of those things. But I hold that as my view, not as a fact, and I know thoughtful people land the other way, and I would rather you argued with me about it than simply agreed. That argument, the one about whether an ending ruins a story or completes it, is the one piece of all this that no telescope and no equation will ever settle. It is yours to make. There is one more thing I want to say about those two words on the hull, the ones we started with. We stayed. At the beginning they sound like a boast, the proud claim of a species that refused to die with its world. By the end they sound like something else, closer to an epitaph, the last true thing that could ever be said about us, carved into a dark that will not remember it. And I think both readings are right at once, which is the whole strange heart of this. We stayed is a triumph and a gravestone in the same breath, a boast that is also a goodbye. We did stay, we could stay, longer than the stars, longer than almost anything, and the same sentence that says so also admits the ending it is racing toward. That is as honest as I can make it. We stayed for a very long time, and that staying meant something, even though it could not last, maybe especially because it could not last. So let me leave you with the real question, the one I genuinely cannot answer for you, because it is not about facts anymore. If survival is finite, if even the longest possible future ends in the cold, then is an almost endless run worth taking? Is it a triumph to carry the only warmth we know of as far into the dark as it can possibly go, even knowing it must eventually go out? Or is it a tragedy to fight that hard for a story that was always going to end? Would you climb aboard that ship, knowing how it has to finish? I have my own answer, and I think it is worth doing, worth carrying the fire as far as it will go, precisely because it does not last. But I will not pretend that is the only honest view, because it is not. Sit with it, argue with me. That is the one part of this no physics can settle for you. I went into this expecting the hard part to be the distance, the cold, the years, the sheer width of the dark between the stars, and all of that is hard, harder than almost anyone lets themselves believe. But it is not the thing that beats us in the end. The thing that beats us is quieter, and it took me a while to really feel it. Everything we are, everything alive, runs on a difference, warmth flowing from something hot into something cold, and doing a little work on the way across. A fire, a star, a body, a ship. They are all the same trick, the same flow of heat from a high place to a low one, and the universe is slowly running out of high places. Star by star, the warmth is being spent and spread out and cooled toward a final state where everything is the same low temperature and nothing flows anywhere ever again. In that universe, there is no fire that can be lit, no thought that can be thought, no ship that can stay warm. So here is where I land. I think we could stay for an almost unimaginable time, long after the sun is gone, long after the last bright stars huddled around the dying embers of dead suns. We could keep the warmth going for a while, but not to the true end. The true end is cold, and it is patient, and it comes for the last fire too. We stayed for a very long time, and then, like everything else that ever burned, we did not. If you want to keep looking at the questions most people would rather not finish, a subscribe keeps you here in the dark with me.